So now we're going to begin a discussion of different systems of numeration. All right, and the first thing I want to point out is the difference between a number, which is a quantity, is actually an abstract thing. Is the answer to the question how many. You can have three things and you can see three things, but you can't see the number three. When you see this symbol, that's not actually the number three. That is a numeral or a symbol that represents the number three. But for instance, we know that this numeral here also represents the number three, right? That's a Roman numeral that represents the number three. And there are various other numerals that we can use to represent the number three. All right, here are some numerals that represent the number 10. Uh, Numeral here, that's the Egyptian numeral. I believe this one is the Babylonian numeral. And here's our numeral for 10. This is a symbol that we use to represent the number 10. So there's a distinction between a number, which is an abstract thing, it's a quantity, and a numeral, which is the symbol, the physical or concrete thing that represents that number. Now, a system of numeration consists of a set of numerals and a scheme or rule for combining these numerals to represent numbers. All the math that we learn, we use the numerals 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We use these 9 numerals in our Hindu Arabic and combinations of these 9. We use these 9 and different combination of these 9 uh, to represent all numbers. So that would be our system that we use, our system of numeration. Here are the numerals, and by combining these numerals, we can represent any number. Our system is a bit more complicated than the systems that we are going to look at in a little bit. In this section, actually, we're going to look at additive systems of numeration, multiplicative systems of numeration, and ciphered systems of numeration. So first, let's take a look at additive systems. All right, so in an additive system of numeration, what we have is an additive system of numeration is one in which the number represented by a particular set of numerals is simply the sum, or what you get when you add up all the values of the numerals. The additive system of numeration is one of the oldest and most primitive types of numeration systems. Here is an example of an early additive system of numeration, Egyptian hieroglyphics. So with the Egyptian hieroglyphics, what we have here, we have our Hindu Arabic numeral 1 is represented by a hash mark, which is pretty much what our 1 is. And the description is a staff or a vertical stroke. That's the description. All right. The number 10 is the heel bone. It's like an upside down U or an arch. So the heel bone represents the number 10. This swirl or scroll, coiled rope, represents the number 100. The lotus flower represents the number 1000. So you see that these are all powers of 10. So it seems as though the Egyptian system is a system based on powers of the number 10. It's a base 10 system. So we have all these symbols to represent powers of the number 10 all the way up to 1 million, which is an astonished person. So I guess they didn't write the number 1 million a lot because that's very intricate in order to write uh, that number. So let's take a look at how we would write a number in this system. So for this problem here, remember the additive system, we're just going to add up the value of all of the numerals present. So write the numeral as an Egyptian numeral. So this number is 3,235,614. Well, these 3 million, since I'm going to add up, I have to make 3 astonished people to represent the 3 million. So this would be 3 million because I have 3 astonished people. One of them, two of them, and a third astonished person would make my 3 million. So this is the Egyptian numeral for 3 million. If I add, or because I have one, two, 3 millions, and I just add those together to get 3 million. Then I have 200,000. So let's see. Here's the Hindu, or sorry, here's the Egyptian numeral for 100,000. So I'm going to make uh, 2 tadpoles. That's 200,000. So here's my tadpole. So I have 2 tadpoles, which is 200,000. Here I have a 30,000. So 10,000, I'm going to make 3 pointing fingers to represent 30,000. One, two, three. 3 pointing fingers to represent the 30,000. Then I have uh, 5,000. So 5,000 would be 5 lotus flowers. So let's see. One, two, three, four, five. One, two, three, four, five. And the lotus flower. So I have 5 lotus flowers. This lotus flower was a bit off. So I have 5 lotus flowers. So let's see, that's 5,000, 5,000. And then I have 600, so I need 6 scrolls or coiled ropes. One, two, three, four, five, 6 coil ropes. And one uh, heel bone or arch. So one heel bone or arch. And then let's see, 4 vertical strokes or 4 staves. One, two, three, four. So there I have 3,235,614 written as an Egyptian hieroglyphic. Okay, so another kind of additive system is the Roman system. And the Roman system is a bit more complicated, a bit more involved than the Egyptian system. So let's take a look at the differences between the Egyptian and the Roman system. Okay, first, in the Egyptian system, we just add the value of all of the numerals. As opposed to that, in the Roman numeration system, starting sorry in the Roman numeration system, starting from the left, we add each numeral unless its value is smaller than the numeral to its right. So as we're going from left to right, if the value of the numeral we're looking at is smaller than the value of the numeral to its right, we're actually going to subtract the value of those two numerals. Um, Only the numbers 1, 10, 100, and 1,000 and 10,000, basically only the powers of 10 can be subtracted, and they can only be subtracted from the next higher number. For example, C, which is 100, can be subtracted from D, which is 500, or M, which is 1,000, but it can't be subtracted from any other numbers or any other numerals. The symbol DC represents 500 plus 600, or sorry, 500 plus 100, which is 600, and CD represents 500 minus 100, which is 400. So depending on the order of the numerals, we would be led to either add or subtract in the Roman numeration system. So let's take a look at an example of that. All right, so in this case, we have this Roman numeral here, and we want to write it as a Hindu Arabic numeral. All right, so what we're going to do is we're going to go from left to right, and you see here we have M, which is 1000. So that's 1000, and then directly to the right I see a D, which is 500, and a C, which is 100. D and C make uh, 500 plus 100, 600, and then another C makes 700. So far I have 1000, I have 700. Now moving along, I have an X and an L. Now X has a smaller value than L. So when I see the X in front of the L, instead of adding the value X and L to make 60, I'm going to subtract the values of X and L, which is 50 minus 100 to make 40. So this XL represents 40. And then VI is 5 and 1, which is 6. So this Roman numeral is 1746. All right, now another advantage of the Roman numeration system over the Egyptian system is that it makes use of the multiplication principle for numbers greater than 1000. What happens is a bar above a symbol or group of symbols indicates that the symbol or symbols are to be multiplied by the number 1000. So for instance, if you see an L with a bar over it, well, that's the number 50, 50, but then you have to multiply it by 1000, so that would be 50,000. All right, so for instance, let's take a look at this example here. Well, this is what I was just talking about. L with a bar over it is actually the number 50,000. So that's 50,000. And then M and then C. Well, then M is a larger number than C. So we're going to take those values and we're going to add them together. M is 1000 and C is 100. And actually, C is a smaller numeral than M. So this CM together actually means 500, or sorry, M means 1000 minus 100, which is 900. So CM actually makes 900. So what we have here so far is we have 5,000, M is, or sorry, 50,000. M is 1,000, so we have 51,000 here. This CM is going to make 900, so we have 900. And then XL, well, XL is going to be 10 and 50. X is 10, L is 50, so we subtract those values because the L comes first to get a 40, 40. And then IV, well, I is smaller than V, so IV is 5 minus 1, which is also 4. So this number here is 51,000, which is the L with the bar over it is the 50,000, and the M is the 1,000. 51,000. CM is 900, XL is 40, and IV is 4. So this is this Roman numeral represents the Hindu Arabic numeral 51,900, or the actual number 51,944. All right. Now we can also do this in the other direction. So let's take a look at these two Hindu Arabic numerals and write them as Roman numerals. All right, so the first one, 6,274. Let's see, 6,000. Well, if I was going to use the subtraction principle, I would have to write 6,000 as an M, or sorry, four C's and then an M. And there's a much easier way to do that, and you never want to write more than three numerals, three of the same Roman numerals in a row. So the way I'm going to write the 6,000 is I'm going to write 6 as VI, VI, and I'm going to put a bar over the VI to represent 6 multiplied by 1,000, so that's 6,000. And then this 200, Well, I can write two C's to represent 200 because C is 100. And then let's see, we have 70. So that's going to be an L and two X's to represent 50 plus uh, 10 plus 10, which is 70. And let's see, lastly, we have a 4, which is IV. All right, so here would be the number 6,274. Here's the 6,000. Here's the 200. Here's the 70. 70 right here. 70. And here's the 4. All right, so the next one we want to look at is we want to look at 14,315. So 14,000. I want to write the number 14. So what I'm going to do is I'm going to write an X, which represents the number 10, and then I'm going to write IV, which represents 4, and when you add those, you get 14, and put a bar over those to represent 14,000. All right, so 14,000, and then I need, after 14,000, 315. 315, let's see, uh, if I write two C's, two C's, which are 100s, and then a D, that would be D, which is 500 minus 200, which is 300. And then for 15, I would just write X, which is 10, and V, which is 5. So this would be the number 14,300 is right here, CCD, and 15, XV. All right, so that is how the Roman numeration system works. Let's take a look at another system. Actually, it's not just a different system, it's a different kind of numeration system. Now, a multiplicative numeration system, they're more similar to our Hindu-Arabic system than additive systems are. For instance, in a multiplicative system, we have the numerals being multiplied by numerals that represent a power of some base. For instance, in our Hindu-Arabic system, our numerals represent our place value for our numerals actually represent powers of the number 10. And the same thing with this traditional Chinese numeration system. The traditional Chinese numeration system, what we have is we have numerals to represent the numbers from 0 to 9. And then we have numerals to represent the powers of 10. And whatever numeral we want from the numerals that represent the numbers from 0 to 9, we just multiply that by the numeral that represents the power of 10 to get whatever number we seek. So for instance, here is a Chinese uh, numeral, and I want to see what Hindu-Arabic numeral this represents. So what I'm going to do is I'm going to take each numeral and multiply it by whatever the power of 10 is. So the first one is the numeral that represents the number 3. So you can see here the numeral that represents the number 3. And the numeral right below it represents a power of 10 that I have to multiply by 3. So the power of 10 that I multiply by 3 is 10 to the third power, 1,000. So times 1,000. This first group of symbols here represents the number 3,000. All right, so the second group of symbols, well, the second thing I see is this symbol here that represents 0. That represents 0 times the next value, which would be 100. So that means there are 0 100s. 0 100s. All right. Then I see the symbol that represents the number 2. So here's the symbol that represents the number 2, and right below it the number that represents, or the numeral that represents the number 10. So I have 2 multiplied by 10 here. 2 multiplied by 10. There's the number 10. And then the last thing I have is this symbol that represents the number 9. So that's 9 ones. That's 9 ones. You don't have to show multiplication by 1. And this would be the number that we would be looking at. This would be the number 3029. So as a Hindu Arabic number, this traditional Chinese numeral would be 3029, written this way. All right, now the next thing we want to tackle is writing a Hindu Arabic number like 6,905 as a Chinese numeral. All right, so let's see. 6,000. Well, that would be 6, which is this symbol here. 6,000 would be this symbol here. So there's 6,000. The numeral for 6 and the numeral for 1,000 are multiplied. 900. Well, here's this numeral for 9. The numeral for 9. And the numeral for 100 is this one here. So that is the numeral for 100. And then 0 tens. So the numeral for 0. Wow, what a numeral. Let's see if I can get it. The numeral for 0 is this thing here. All right. And then these little things down here. And I think I have it there. So that would be the numeral for 0. There are 0 tens. And then 5 1. So I just need the numeral for 5, which is, all right, let's see, 3. Uh, 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 numeral for 5 looks something like this. So there we have it. That would be the numeral for 5, and I would have the number 6,905. And that would be the traditional Chinese numeral to represent that Hindu Arabic number. So that is how we work with the traditional Chinese numeration system. Now, yet another kind of system of numeration is a ciphered system of numeration. And in a ciphered numeration system, there are numerals for numbers up to and including the base, and for multiples, not just powers, but multiples of the base. The numbers represented by a particular set of numerals is the sum of the values of those numerals. So if you notice in this Ionic Greek numeration system, the numbers from 1 to 9, the numbers from 1 to 9, uh, and 10, which is the base, including 10, are given here. So we have powers from 1 to 10, up to and including the base. And then we have numerals to represent the multiples of 10. So 10, 20, 30, 40, 50, 60, all the way up to, in this chart, we have up to 900, which is 90 times 10. So we have multiples of 10 being represented here uh, in this system. All right, the next thing we want to look at. Okay, so here is a problem from the Ionic Greek numeration system. I want to write this Ionic Greek numeral as a Hindu Arabic numeral. All right, so I see here that there is a beta, and beta represents the number 2. So this is beta, which is 2 times, well, this iota in the corner here means to multiply by 1,000. So that is 2,000. All right, I see omega, and omega is the number 800. So that's 2,800. And then pi is 80. And then the last one, the last number here is gamma, and gamma is the number 3. So this Ionic Greek numeral is the Hindu Arabic numeral 2883.